Okay. Good afternoon, everyone. Hello, can you all hear me, right? Okay. Give me 1 second. Those of you at the back, can you all hear me? Okay, thank you so much. Okay. Uh, just want to see if this is working. Hello. Okay, so I want to welcome you to my lecture today. Of course, today we're going to start from the material that I share on Canvas. I want to believe every one of you have access. Do you have access to this material, right? Okay. This is what you're going to be reading ahead of lectures, okay? Okay, so I want to welcome you once again. And I'm also going to say this. I'm recording, okay? I'm going to be recording my lectures, and I'm going to be publishing that on Canvas, okay? So that you're actually going to have another opportunity, maybe to catch something. Does that make sense? Okay. Now, the other time I introduced you to this course, Introduction to Statistical Analysis, I actually go retrospective of trying to figure out reason why you're doing statistical analysis. Okay. I remember that I said we live in an environment where we got a lot of variations, different things happens in different days. And because of that, for us to be able to understand the environment that we live, we need to have knowledge. Okay. And I remember knowledge is going to come from information that we got. Information will come from data. Okay. And when you collect data from the field of inquiry, the information you are looking for is not readily available. Okay. Something needs to be done to data for you to be able to have access to the information. And what are we going to do to data? We're going to use model. Okay. I told you the other time, we're actually going to use statistical model, okay, to extract information in the data. Okay. And now what I want to walk you through today, moving forward, okay, is to introduce you to some fundamentals, okay, on, you know, how do we collect data, you know, in what discipline, and so on like that. And that is why I'm actually introducing you to statistics, okay? What we do in statistics, okay, we actually want to get information from data, okay? And of course, I'm actually going to tell you what do we need to do before we'll be able to achieve that. And that is why I first want to give you the definition of statistics. Now, all what I need from you today, listen, ask questions where necessary, because what we're going to be doing now, they're going to be very, very crucial. Now, I'm going to start with the definition of statistics. I'm going to give you the definition of statistics according to American Statistical Association. I'm going to give you my own personal definition of statistics because there's so many form of the definition of statistics, but I'm going to tell you in every statistical definition, you're always going to see learning from data. Does that make sense? Now, according to American Statistical Association, statistics is the art and science of learning from data. I'm going to say that again. According to American Statistical Association, statistics is an art of, art and science of learning from data. Okay, we actually want to learn from data. Don't forget, what do we want to learn from data? You actually want to learn information, and that very information will translate into knowledge. And the moment you got the knowledge, then you will be able to understand and secure your environment. Okay, now I'm going to give my own definition now, okay, about statistics. So statistics can be defined as a scientific method of collection, underline the word collection, okay? Collection, compilation, you compile. When you collect data, you compile data because the data is going to be massive in nature, okay? Compilation, summarization, okay? You're going to summarize your data, okay? I'm going to walk you through in this course how we summarize data. So I've mentioned collection, compilation, summarization. After summarization, you have analysis. After analysis, you have interpretation, okay, of a numerical fact. When I say numerical fact, I mean data, okay? So why am I collecting data? Why am I compiling data? Why am I summarizing data? Why am I analyzing data? Why am I interpreting data? Because we want to be able to provide, answers to practical problems. There's always going to be problems. I don't know where problem come from, but there's always going to be. When the problem arrive, okay, then how we can manage it. Okay, so the reason why we're doing all of that is because we actually want to provide answers to practical questions. Okay, there's so many questions that may come from medical field, from economic field, from psychology, from sociology, and so on like that. I want to tell you, of course, if we're able to get the relevant data, then we'll be able to provide solution answers to all of that. So that's exactly what we mean. Now, I think you now understand what statistics, you understand the definition of statistics now. As I can see, collecting, organizing, interpreting, and at the end of the day, when you do all of that, we want to learn from data. Okay, now the course goal. Okay, the course goal is more or less, okay, what is the goal of statistics? Okay, the goal of statistics is what we actually want to do is to use statistical methodology, okay, to translate, okay, that very data into knowledge. Okay, you can't translate data into knowledge without you using statistical models that we call statistical techniques. Okay, I told you the other time. Okay, information is hidden in the data. Okay, we need statistical model to be able to have access to the information, and that is exactly what we're trying to do. But you know what? I'm going to give you, let me tell you this. We don't do what we do. We got a reason why we do what we do. So what are the likely questions begging for answers? Okay, before we intend to use statistics. I'm going to give you some example now, and I need you to also give your own example. Let me tell you, when you are learning and your professor give you example, you need to try as much as possible to create your own example. Okay, when you create your example, you actually understand the information. Now I'm going to give you some example now. Okay, this instructor material was actually produced as at the time when Hillary Clinton was contesting for president in the United States. But right now, I'm actually going to reframe this. There's a question coming from political faith. How can we estimate the percentage of American citizens who will vote for a particular candidate if the presidential election were held today? You know, why are we so curious? Okay, I know there's going to be a presidential election in November 5 in the United States, but today is September 6. But why do we want to go into the future? We want to go into the future because we know anything can happen. There's variation, and supporters of a particular politician may want to know the chance. If you want to answer this particular question, then we're actually going to use statistical methodology. When you listen to Fox News, CNN, MSNBC, and so on like that, TVs in the United States, you're actually going to hear them reporting a polling results. Even before election, they go into the population, they interview people, and they report that. They use statistical methodology to do that. Okay, that is one of the questions. Another question we may want to answer. Do you know we may want to see, even within the political field, we may want to see what is the relationship between the percentage of votes a Republican candidate got in 2016, okay, and compared to in 2020. The former President Trump contested in 2016, also contested in 2020. Now, if we can use statistics to be able to find, is there any relationship between the percentage of votes the former President Trump got in 2016 and what he got in 2020? Statistical method can actually be used to figure that out. And let me also tell you, I want to go into bank right now. I want to leave politics now. I'm going into banking system. I may want to know what is the relationship between the proportion of customers who use a drive-in facility in a bank and the proportion of customers who use a walk-in facility. In a bank, customer come in, either they drive-in or they walk-in. Has anybody ever been to the bank before here? Did you walk in or you drive in? You do both, right? Do you walk into the bank to get service or you drive in? At times you drive in, you're going to be in your car, you just use the ATM. We do that all the time. Okay, the bank officials may really want to know, is there a relationship between the two? And if a relationship exists, can we actually say this cause this? Okay, another example that I gave here. Is there an association between smoking and divorce? If you take a look at what I have, and if association exists, does that implies that, the smoking actually cause that? Okay, let me tell you this in statistics. Even though association exists, even though relationship exists, association may not imply causation. Okay, I'm going to give you another example now. We're still going to go into all of that. For instance, if I look at the relationship between crime rates and sales of ice cream, okay, maybe I call crime rate to be independent variable. You're still going to hear, I'm still going to discuss all of that. And dependent variable is the sales of ice cream. Okay, let's say relationship exists. Okay, now if relationship exists, that doesn't mean, when relationship exists, if the relationship is positive, we'll be saying, oh, the more crime, the more sales of ice cream. Okay, but let me tell you, that doesn't imply causality. That doesn't imply that when I have more crime will lead to more sales. No, That is not what we mean. When you are trying to establish a relationship between two variables, that doesn't mean one causes the other. Am I making sense? Okay. Now, like I said, ask your, you can bring your own examples here of what a practical question could be. It could be, on average, how many hours, okay, the student from University of Minnesota commit to study in a week? You can ask your own question. Okay. Now I want to move right now. Now, in statistics, we got three aspects. Okay. If I want to use statistical approach, okay, if I want to use statistical approach, we got three aspects of statistics. Number one, design. What do I mean by design? Oh, what I mean by design is planning. I'm actually going to plan. How am I going to get the right data? Oh, I got a practical question in place. Okay. The necessary machinery that I put in place to ensure that I got the right data. I use the right statistical technique. Because let me tell you this, you are not likely going to have answers to the question if you don't collect reliable data. Okay. Now, what are the totality of steps that I need to take to ensure that I got reliable data? I use appropriate statistical methodology, okay, to be able to arrive at a decision. We don't want a situation whereby we're actually going to take a decision that we will regret. We don't want that. And that is why at times it looks as if our models are failing us. Our models are not failing us. Maybe we didn't do the right thing. And it has to start from planning. Okay, planning how to obtain data to be able to answer the question of interest. And that very planning will involve you going out to obtain the reliable data. Okay, not only that, you using appropriate statistical methodology, because there are so many statistical methodology. So what we're going to teach you here is when this situation arises, what is the fitting or what is the appropriate statistical model or technique to use. Does that make sense to everyone? Okay, you know what? Statistic is like a story that goes on and on and on. Now, after doing that, the next thing is to have a description. Oh my God. Do you know that next week we're going to start chapter 2? I will advise you read chapter 2. What we're going to be doing in chapter 2, we're actually going to be describing our data. If we want to describe, we can describe graphically, we can describe numerically. Okay, so what we're going to start from next week, we're actually going to be exploring our data. Let me tell you this. Relationship between statistician or researcher and data is the same as a relationship between a doctor and a patient. Okay, now this guy is sick. Okay, this guy is sick. This guy right here is sick. Okay, and of course this guy is a doctor, right? Before doctor can actually make a very reasonable prescription that work, then the doctor must understand the patient before before statistician or researcher can apply the right statistical methodology to data. That statistician must understand the nature of the data, that different kind of data. Okay. Now, so by describing, we are summarizing. And that is why at times you see different kind of beautiful pictures like pie chart, bar graph, and so on like that. We're going to discuss them. We don't just use them. We got a reason for using them. I'm actually going to walk you through in this class what are the appropriate graph to use for a given problem. All of that is describing. Okay. Now, which is that for under description. Then the third aspect of statistics is inference. This particular aspect is very, very important. What do we do in inference? Inference is a judgment. Inference, because in statistics, if I want to answer a practical question, okay, I need to first identify what I call, oh, let me do this. Oh, give me 1 second. Okay, I need to first identify the target population of interest. Okay, if I want to conduct a research, if there's a practical problem, what I'm going to do is to first identify what is the population of interest. Okay, when I identify the population of interest, then you know what? We do not have resources to study everybody in the population. I'm going to say that again. We're limited by budget and time in research. Because of that, we are not going to study everyone in the target population. What do we do then? We take a sample. We take a sample. Okay? Okay? Population is the totality of the subject. Okay? Why sample is just a subset of the population. Okay? Now, we do, because we're limited by budget, but let me tell you this. How we take our sample matters. How we choose sample from the population matters. We got to choose that sample in such a way that is a very good representative of the population. Now, let me tell you this. In statistical analysis, we have justified reason why we take sample. It's going to save time, okay? And it's actually going to be cost friendly. And let me tell you this. Imagine a doctor, okay? This guy is a doctor here, right? And this guy is sick, okay? And this doctor want to test this guy. Is he going to extract the whole blood in this guy's body? If he extract the whole blood, what is going to happen? That could amount to suicide, right? Okay, so the whole blood is a population. I don't need to study everything before I have the idea of what is going on. And you know what the doctor is going to do? He's just going to take a sample of blood and believing that sample of blood will actually be a good representative of others. Now, what do we mean by inference? Inference means making judgments, generalizing the results that you got from sample on the entire population. That's what we mean by inference. I'm going to say that again. Okay. You know what we mean by inference? It means I've taken a sample, I've gotten a result, and right now I want to generalize it on the entire population. That will now look as if I've studied the entire population. I'm actually going to give you some example. You're going to see right now. Now, because I mentioned population and sample, I need to tell you the meaning of population, and I also need to tell you the meaning of sample. I've already said that. But I want to give an example right now. Okay? I want to give an example right now. Okay? I actually want to give example of population. Like I said, that's a collection of unit of interest. Okay? Now, let's have an example. Adults in Minneapolis. Oh, the number of students in the University of Minnesota. Okay? So when you're talking about that, we're talking about hall. And that was why I said, take a look at that. Choose from depending on what you're looking for. We'll define it to the totality of the subjects. That is what we mean. I also wanted to give your own example as well. Now, I want to move right now. Okay, now, let me first talk about subject before I talk about sample. A subject actually refers to individual units in a population. Okay, like when I want to study people, maybe adults, I'm going to say adults. And a subject could even be a state. We can have a state, and a subject could be a county. Like the other time I was talking about what a particular presidential candidate got in 2016 and what he got in 2020. I was referring to across counties in the United States. So county is a subject. Okay. Now, to the sample now. Okay, I said, very rarely can we observe entire population of interest. That doesn't make sense. We don't have resources for that. What do we normally do? Okay, instead, we observe a sample and use it to learn about the population. Oh my God, let me tell you this. When you have a sample, the reason why you are getting sample is just you want to have the idea of the totality of the population. But let me tell you this. You got to make sure you choose a representative sample. Okay, we're going to teach you in this course how you can choose, okay, a sample that will be a good representative of the population. I remember a time my wife was cooking, and I can perceive the aroma from the food. Okay, do I need to taste everything in the pot before I know how it tastes? No. But I'm going to tell my wife, can I just have a sample of that? But you know what? Before my wife can dish out a sample of that, I'm going to say, baby, steal it so that I can have homogeneous mixture. We don't want a situation where she's going to dish a part where ingredient is highly concentrated. That is going to be bias. Does that make sense to everyone? That is what we mean. So a sample is a subset. Few. Instead of few, the population is the totality. The sample is a subset. Okay, the next thing I want to talk about now. So far, so good, right? Okay. Now, the next thing I actually want to talk about is this. Let me come here right now. Oh my God, I'm actually seeing some kind of um assignments. Do you know that you're going to be given give me 1 second, let me take this guy up. You're going to be given a scenario, and you know what they're going to ask you? They're going to ask you, in this scenario, what is your population, what is your sample, and so on, like that. Like in this question now, suppose we want to know what percentage of Minnesota adults, pay attention, they said Minnesota adults, okay, own a firearm. Since it is impossible to ask all adult Minnesotans, we instead take a pool of 1,000 Minnesotans by selecting a sample from the phone book. Now the question asks, what is the population? Of course, that will be all adult Minnesotans. This population, okay, does not involve adults in Chicago, only in Minnesota, because we actually want to know something about adults in Minnesota. Does that make sense? Okay, what is the sample? Of course, the sample will be the 1,000 Minnesotans selected. But you know what you're going to learn in this course as time goes on? We're actually going to walk you through how to decide on the sample size that you're going to choose. How did they arrive? How do they know that they're going to choose 1,000? We're actually going to walk you through that, okay, as time goes on. Now, the question now asks for that. Is this a good sample? Okay. And we say no. Some people don't have phones. Those who do not have phones may be the one that have genuine information. In the process, you know what has happened? Then your approach has neglected them. Okay. Now, I said have unlisted phone number. Some could have phones, but their numbers are not listed. And that is the reason why this is not a good approach. Can somebody tell me for extra credits? I don't joke with my extra credit. Can somebody tell me another reason why this may not be a good representative, a good sample? I got three. Okay, you, four. Oh my God. Is that what you guys also want to say? What is your own? Nice one. Another person? Bias? Another person? Oh, you mean like a small number, right? We still need to decide on what number is small, what number is large. That's a very good one. Another one? Exactly. Now, you know what? Those of you that answer my question today, good job. Send me a message for extra credit. All of you that answer my question, you actually provided a very reasonable response. Thank you for sharing. Okay, now I want you to take a look at this. Okay, I want you to take a look at what I want to showcase right now. What makes a sample to be a good sample? Okay, so look at the question. What make a good sample? Oh, it should be a representative of the population. So which means part of what we're going to be doing in this course, we're going to guide you on sampling techniques to use when you are choosing your sample. Okay, so we're actually going to walk you through all of that. And that was why I said if your sample is random, if you give equal chance to every subject in the population when you are choosing your sample, then your sample is going to be a good representative. I'm not just going to choose, maybe I want to conduct a study in this class. I'm not just going to choose on somebody because the person I'm choosing is beautiful. Does that make sense? I'm not going to do that. Or because the person is because I know the person, or the person is my friend. I'm never going to do that. Okay, so that kind of sampling is may not guarantee a representative sample. Why do we need a representative sample? Oh my God, we need a representative sample because whatever we get from the sample, we're going to generalize it on the entire population. Does that make sense? Now, then where do statistical method come in? Okay, the statistical method comes in when you are having your design, when you are having your plan to collect your data, the method of data, and so on like that, to ensure that at the end of the day, you have a reasonable result. Then statistical method will comes in when you are trying to describe your data. Describing your data, it depends on what you are looking for. If I want to describe my data graphically, why am I doing that? Oh, maybe for comparison. Oh, election is coming, and maybe I want to know what is going to drive us a voter to the voting, to the polling station. Is it going to be a reproductive rights? Or is it going to be economy? Is it going to be immigration? Is it going to be this? Is it going to be that? Okay, now I need to describe that graphically, even though I know the numbers, I want to describe that graphically so that people will be able to see, the comparison. Okay, we got several ways why we describe our data. Okay, at time we can generate a plot called histogram. Has anybody heard about histogram? Histogram. Oh, good. Okay, we're still going to do that in this course. Histogram. Oh, I want to know the shape. I want to know the distribution of my data. Okay, like I said, we have different kind of intentions. We don't just do what we do. We got reason why we do what we do. So by describing, okay, we can describe graphically by constructing plots, and we can also do that numerically. Then after that, we perform a statistical inference. Statistical inference is making a judgment, okay, where we generalize. Okay, now another thing I want to point your attention to. I think this class starts 12:20 to 1:10, right? Okay. Now, another thing that I want to point your attention to, please, I need you to be focused here, okay? I need you to understand this. What do we call parameter? I'm going to tell you this. Parameter is whatever information we're seeking for, okay? Anything at all that we want to know about. Oh, I want to know about what is the proportion of Americans that will vote for a particular candidate? Or what is the proportion of a people in a country that are living in absolute poverty? Okay, or what is the average? What is the average household income in a particular country? That's a parameter. Okay, and that is why we said it is a number that describe a population. Because you're only going to, if you want to get parameter, we go to the population. Oh, I want to get the average of all. Oh, I want to know everything about everything. That's a parameter. Okay, but you know what? We do not have resources to study population. Unfortunately, we are not going to get parameter because the only way to get parameter is when you study everybody. But you know what? The good news is, okay, we're going to take a sample. When we take a sample, whatever information we get from sample is what we call statistic, not statistics. Okay, not statistics. I said statistic. Okay, statistic. Okay, if I take a sample and I get a result from a sample, it could be mean, it could be proportion, it could be whatever result that you got from a sample is called statistic. But if you have access to the whole population, okay, and you get a result, the result you get is called parameter. And let me also tell you this. If everything is good, if the method of collecting data is okay, if you have used an appropriate statistical method, if you have, let me just say, you've taken a representative sample, then you know what we're going to do at the end of the day. Then we're going to use statistic to represent parameter. Does that make sense to you? Okay. What do we say we're going to do? That was why I said we use sample statistic to estimate population parameter. That's what we do. Okay. Now you know the difference now between parameter and statistic. Now, I'm going to go to an example right now. And like I said the other time, we can actually give you a scenario, okay? And we can ask you to identify identify population, identify sample, identify statistic, identify parameter. Does that make sense? Now, let's take a look at this scenario together now. Okay, and we can also ask you to identify variable. Okay, um, let me write it so that you know what I'm talking about. Um, Variable. You say what? No. Variable, that's a good question. Okay, variable is not a subject. You know, let's say subject is student, right? I'm just assuming. Maybe what I want to measure is what is the average score? Then score is a variable. Oh, what is the height? Height is a variable. Oh, I'm a doctor. I'm looking into the blood pressure of my patient. Blood pressure is a variable. Does that make sense? Okay. Now, here now, we want to know the average height. Then height is a variable. Does that make sense? Okay. We want to know the average height of all. Please take a look at this. Do they say some students? They say all students. Okay. Of all students at the U, it is logistically impossible to measure everybody. Instead, we take this class. Now, we're taking this class as a sample, then measure height and average them. Now, let me demonstrate practically now. We're interested in knowing the average height of students in the University of Minnesota. And we say, okay, we don't have resources to study everybody here. Let me just use this class. If I want to use this class, I'm going to go from one person to the other. I'm going to measure the height. Okay. Why is the height variable? Okay. Because the height of this person will be different from this person will be different. That is the stochastic nature of the world. That is the variation we're talking about. And I told you the other time, statistics thrives in variation. Now, population will be all you students. Sample will be, I mentioned this class in the scenario, right? Will be this class. Does that make sense? Then parameter, okay, will be average height of all you students. That is the parameter. Now, what will be the statistic now? Okay, the statistic will be the average height of this class. Does that make sense to you now? But let me tell you this. Choosing this class is bias. Maybe I'm choosing this class because it's my class. Okay, that will introduce bias. Okay, I'm actually going to tell you the way we can do it. When we want to choose a random sample, we're going to grab a paper. We're going to give all classes in the University of Minnesota number. Oh, DBD class is number 1. We're going to write 1, we're going to cover it, we're going to put it down. Then every other class, number 2, number 3, then we're going to, as if we are doing lottery, right? We can even close our eyes, pick a number, and when we pick a number, it could be any class. That is what we call the randomness that we have incorporated. Does that make sense? Okay. Statistics is like a story that goes on and on and on. What is the next thing to do in the next 8 minutes? Okay, which is the last thing. Very, very crucial. Some of you have been sending me message about discussion. Some people are missing discussion with lecture. When you hear discussion, we're talking about lab. Okay, TA is the one, my TA is the one that will walk you through the lab. Okay, in lab, all what you're going to be doing in the lab is my TA is going to walk you through how you can implement, how you can conduct statistical analysis using software. How? Does that make sense? Okay, now I want to talk about the role of computer in statistics. Let me say this. The role of computer in statistics cannot be overemphasized. Number one, the data collection and storage. Imagine you want to collect thousands of data, okay? If you do that manually, of course, you're actually going to mess up. You're going to mess it up, okay? And with computer, we can collect data and we can store it, okay? And that is why computer play a role in statistics. Number 2 is when you want to talk about data processing and management, okay? You want to process your data. Of course, we put data in a warehouse, in a database, okay? So without computer, we may not be able to do all of that. Another thing I'm going to talk about, the other time I said we normally describe our data graphically. Oh my God, if you use computer, it will enable you to have, very beautiful picture of those graphs, which we call data visualization. Imagine I asked you to plot a graph and I said, okay, take a pen, take your pencil, draw. Oh my God. It may not be as beautiful as the one computer is going to generate. Okay. And not only that, we are in the era of big data. Okay, if you want to perform a sophisticated analysis, we cannot do that manually. We're actually going to use computer. Okay, so the role of computer cannot be overemphasized. And what about the software? Okay, the software, without computer, there's no way we are never going to have a platform to use statistical software like R, like Python, like MATLAB, SAS, and so on like that. Okay, and that is the reason why I will advise that you attend the lab. Okay, the lab is very, very crucial to passing this course, because when we're given assignment, we actually are going to ask you to make use of R software. We choose R among other software because of its simplicity. You can learn R in a week or a month and be an expert in R. Nobody taught me R. I actually look at it myself. So it's because it's easy to learn and you don't need to pay money when you are downloading it. Of course, that is why we actually we actually choose that. It look as if I shouldn't finish. But you know what? My time is up. Is there any question before I go today? Ahead of Monday, you need to read chapter 2. This is where we're going to start from on Monday. I'm going to show you right now. Yeah, you see,